well, our next special guest speaker. I think that we've all asked this question at least once in our lives, and that is, could Jurassic Park be real? Could Jurassic World really happen? Could we really bring dinosaurs back to life? And our next special guest speaker is going to be touching on those subjects exactly as well. It's very exciting stuff. This man has worked with Steven Spielberg as a technical advisor. Ooh, oh, that's nice, yes. As a technical advisor on Jurassic Park and also the new Jurassic World films. He is credited as finding one of the largest concentration of dinosaur bones in the world ever. Like, just this incredible achievement. If that's not an achievement, I don't know what is. I mean, a pre-round of applause, I think. Yeah. But not too much, not too much. Okay, so he's cutting me off. This bit isn't planned. He's shut me off. Jack Horner, everyone!
We don't care about a bunch of old bones, do we? It's gamers, I tell you. I've never been to one of these before. It's interesting to see everyone. It's interesting to see what you do and what you make. You do all know that Jurassic Park and Jurassic World are fiction, right? Right? Okay. All right. So. It's interesting, you know, when I was asked to work on Jurassic Park and Jurassic World, Steven Spielberg basically said, we want to make it real. Well, Steven, you have to actually make it real. Think about this. Everything about Jurassic Park is fiction, right? Right? All right. What I want to do is just sort of talk about the origins of Jurassic Park and Jurassic World, and I assume you all know it came from a book, right? So, the paleontologist that Michael Crichton had invented worked at a place called Egg Hill, which is very similar for some reason to where I worked, called Egg Mountain. Egg Mountain is a place that we discovered in 1978. Back before 1978, people thought that dinosaurs were really just overgrown lizards and very reptilian. They were all green, and they all wandered around looking for a place to go extinct. And after 1978, we changed that a little bit. The dinosaur renaissance was coming on, and people were starting to think about dinosaurs as being more related to birds. But they didn't have any evidence. And in 1978, I was lucky enough to find a nest that contained baby dinosaurs. And they were the first baby dinosaurs found in the world. Now just think about that. I mean, dinosaurs are common. We find them all the time. But people hadn't found juvenile dinosaurs. And the reason they hadn't found them was because every time they found a dinosaur, they assumed it was an adult. Now, why that was, who knows? But these were scientists, and quite literally, every time they found a dinosaur, they thought it was an adult. I found a nest, a bowl-shaped structure full of baby dinosaurs, little tiny dinosaurs, and people were arguing with me that they were adults. Scientists were arguing with me that they were adult dinosaurs and that they lived in a group at a little herd. These were dinosaurs that are 3 feet, that are 1 meter long. Just tiny little things. But that's the preconceived idea that people had at the time. So I was fortunate. We found a nest of baby dinosaurs. We found the first dinosaur embryos in the world. The first embryos were found because I had a hammer. People thought eggs were rare. They thought they were precious. They had hundreds of them. They had collected hundreds of eggs from all over the world, and no one had ever thought to break one open. I got to find the first dinosaur embryo in the world just because I had a hammer. So we found clutches of eggs. We found a whole bunch of things. We found evidence. We found a whole bunch of egg nests together, clutches of eggs, clutches, babies, and so on, in great big areas where obviously they had colonial nesting. We've also found a massive accumulation of dinosaurs, all one species, and we've estimated now that there's about 127,000 skeletons at this one spot where they died in a catastrophic volcanic event. So all of this stuff, you know, sort of started fueling the whole idea of dinosaurs being different, that they did, in fact, make nests like birds, and they did bring food to their young, feed their babies, and that they nested in colonies, and that they traveled in gigantic herds. So it was sort of this stuff that early on in the early 70s all the way up into the late 80s, I wrote a book about it, and then 2 years later, so my book came out in 1988, and 2 years later, Michael Crichton wrote his book, Jurassic Park, and of course, he talks about Egg Hill and the dinosaurs and so forth and so on, and he came up with the character Alan Grant, which fortunately didn't get eaten. So I was brought on by Steven Spielberg. I hadn't really met Michael Crichton. I met him on the way to the premiere of the movie. And at that time, he asked me if it was all right if he made a character based on me, which was an interesting time to ask. And Steven asked me if I would work on the movie version, and he said my job was to make sure the dinosaurs looked as accurate as possible. And of course, that meant as accurate as possible and as accurate as possible in computer graphics. And of course, if many of you probably know that the computer graphics were brought in to Jurassic Park in the middle of shooting. We started with claymation, and computer graphics were brought in the middle. And so you know, the very first scene that you see in Jurassic Park, where they're sitting on the hill looking out, this is basically the first computer graphics in this movie. And Alan Grant is looking out and, you know, basically says they really do travel in herds, and that's cool because obviously that's what I keep saying, right? The nice thing about being the technical advisor is you can prove yourself right. So I was brought into all of the movies and you know, talked to the actors about how to pronounce their words right, and argued with Steven a lot, and he always won. And so we see the movie the way we see it. I did get to introduce Spinosaurus into Jurassic Park 3. We knew at the time that it was a fish eater, but we wanted a dinosaur big enough to kill T-Rex realistically. Obviously, it couldn't really do that because it ate fish. But it looks good in the movie. All right, so everybody knows Jurassic Park, right? We know how it all started, and we know how you get a dinosaur according to Jurassic Park. You just go out and find yourself a piece of amber with an insect in it that obviously sucked blood out of dinosaurs, and you drill into it, you get your DNA out of it, you clone your DNA, you stick it in an ostrich egg, you wait for a little while, and out pops a dinosaur. And then you get a whole bunch of them. And once you get a whole bunch of them, then they conspire. Because they're social. They conspire. And of course, they eat everybody. They eat the bad people. Did you notice they only ate bad people? And in the first Jurassic Park 3 movies, 1, 2, and 3, they only ate men, bad people. They didn't eat kids, they didn't eat women. we didn't get a woman eaten until Jurassic World, and she was a bad woman. So dinosaurs are cool. They only eat bad people. And this, of course, is the most popular bad person. He is a lawyer. Yes. So anyway, that's the premise of Jurassic Park. And of course, we can't get DNA out of we do have insects in amber. We've never gotten any kind of biomolecule out of it. Even if we did, we just haven't got a clue how to actually clone it. So we couldn't do that anyway. And of course, we're not going to stick a dinosaur of any kind just in any old ostrich egg, especially since the dinosaur didn't make it. So we need a different kind of birthing chamber. And we'll get to Triceratops in a minute. When I worked on Triceratops back in the 90s, this is exactly what I thought Triceratops probably did look like. But it's been a long time. It's been 25 years. That is completely wrong. So the way the dinosaurs look now, we know in Jurassic Park is incorrect. So one of the cool things that was happening at the same time we were making Jurassic Park, when Jurassic Park came out, I had a government grant to actually attempt to extract DNA from a dinosaur. We did not know we couldn't find DNA at that time. And we had this pristine Tyrannosaurus rex that had been collected in eastern Montana, and my former student, Mary Schweitzer, who studied biomolecules, attempted to get DNA out of this dinosaur. So we took the thigh bone, we drilled into it, and we took some bone structure out of it. And the coolest thing is that when we took some of this bone tissue out, there was actually something in it. Inside the blood channels, the channels that go through the bone where the blood vessels would go, we found some red spherical structures that were the right size and the right shape for red blood cells. Now we know that red blood cells would have a high unlikelihood of being preserved. And so, but it still was the right shape and the right size. And so we went into those particular cells, into what looked like the nucleus, and tried to find something. And of course, we didn't find DNA. But what is interesting was that we did find heme. This is a paper that we wrote, Heme Compounds in Dinosaur Trabecular Bone. Heme is the biological iron origin of hemoglobin. We did find something, some remnant of the blood. We also found some other biomolecules and some other structures. But nothing was preserved very well. It looked like it had broken down. It looked like it had deteriorated, probably from just touching the atmosphere. And so in 1999, I undertook the largest expedition for dinosaurs that had ever been done. We went out into eastern Montana, where Tyrannosaurus rex comes from, and went looking for more of them. And I assume, so this is where we found one. When you're looking for dinosaurs, you're usually walking around looking at the ground, hoping that you find them sort of weathering out at the surface. In this case, we found one on a cliff. And as you can see, there's a lot of cliff above it. And so what I do, so this is the cool thing about being a paleontologist. As a paleontologist, I can go around, find a dinosaur, and then go out and get a whole bunch of graduate students to dig it up. So that's what I do. That's what graduate students are for, and all you have to do is feed them sandwiches. And they will dig and dig and dig. And these people dug for a month, and it was a huge excavation, all done by hand. The only way we could get equipment in even was by helicopter. And It was a beautiful specimen. The bones were preserved exquisitely. It wasn't a very big T-Rex. In fact, it's what we would call a teenager. And it wasn't very complete. We only found the bones in blue. The rest of it apparently had weathered away. But the bones were pristine. It was one of the best preserved dinosaurs I have ever seen. And so, you know, from my perspective, there's more information inside a bone than there is outside of a bone. Remember when I said I broke an egg open to get an embryo? I mean, imagine, you know. So I do the same thing with bones. And people at that time thought bones were really precious. Nobody wanted to cut them open. And I cut them open all the time just because there's so much information inside. And so when we cut this particular T-Rex open, we found medullary bone, medullary tissue. And here it is in a chicken, here it is in a dinosaur. Medullary bone is actually the calcium buildup inside of the leg bones when a dinosaur, or when a bird is pregnant. So it's the calcium used to make the shell of the egg. So we knew that we had finally found, we had sexed a dinosaur. We have a female dinosaur. That was pretty cool. We were also able to look at so the medullary bone is actually this stuff here. It's right at the edge. It's right inside the medullary cavity. So it's just this thin layer of material. So we went deep into the bone and were able to tell just by growth lines in bone, all animals, mammals, dinosaurs, everything has annual rings, just like trees. You can just count them up and you can tell how old the animal was when it died. So we called this dinosaur B-Rex. B-Rex died at the age of 16, and she was pregnant. So we went again into this tissue, not only looking at its age, but looking at the tissue itself. It was, like I say, preserved very well. We sent some of this stuff to Mary, and Mary put it in acid and dissolved the bone away, and we ended up with 65-million-year-old, clear, flexible blood vessels with stuff inside of them, those little red structures that have heme in them. We also looked at some of this material, and so this is a blood channel, and this is where we would get the blood vessel. And here are little areas where cells would be, the osteocytes that actually laid the bone down 65 million years ago. We etched the bone away there, and we actually found osteocyte. The arrows are going somewhere. Here's an osteocyte. And it has the right structure of an osteocyte. It looks, for all the world, like a modern day one. Here is one. You can see the nucleus inside of it. And of course, with the nucleus, we went after DNA and didn't find any. We didn't find any DNA. We didn't find anything in there. So I thought maybe again that it looked deteriorated. So we had taken the dinosaur out, we had extracted the bone material, we had put it in acid, and then sent it to Mary in North Carolina. And it took a while for that all to happen. So I thought maybe we needed to get it fresher. So we built a molecular laboratory in the back of an 18-wheeler trailer and took it to the site and then did another extraction, and the cells came out a lot better. The nucleus was in much better shape, but again, no DNA. We did not find any DNA. But we did find collagen, the protein collagen. So proteins were holding up, but DNA wasn't. That's pretty cool stuff. I mean, that is 65-million-year-old cells from a dinosaur. So what that means is basically deep inside of that bone is an environment where bacteria did not get to. Bacteria is what actually eats away soft tissue when an animal dies. And so So there are environments where that will preserve. So we couldn't get dinosaur DNA. And so, you know, I had worked on Jurassic Park. I really like the idea of bringing dinosaurs back. I want one really bad. And I tried to find the DNA to make one, but we didn't find that. That didn't work. But, you know, birds are already dinosaurs. Everybody knows that, right? Birds are dinosaurs. So you don't really have to. I mean, we already have them. But if you look at the two, well, we're not going to make movies about chickens. We do make movies about velociraptors. So all birds are dinosaurs, not just one kind of, not just one kind of bird, but all of them. All birds are related to each other. And so, because birds are all related, and because birds are dinosaurs, and we separate them only into the fact that some of them fly and some of them don't, so we have avian dinosaurs and non-avian dinosaurs. The thing is that we know that non-avian dinosaurs gave rise to avian dinosaurs, and so the next best way to try to make a dinosaur is to reverse it, to take an avian dinosaur and try to make a non-avian dinosaur from it. And so that's what we do. We're working on that project. I wrote a book about it in 2009. We've been working on it ever since. We built a laboratory, and we are trying to take our chicken, our bird skeleton, and turn it literally into a dinosaur, a cool-looking dinosaur, right? Just make it cooler looking. So we want to change its head, because obviously, you know, a bird head isn't really scary looking. So, and it doesn't have teeth in it. So we need to change its head. We need to change its arms, because they have wings. We need arms back, and we need a tail. So if we were able to do just those three things, we have to change the legs a little bit just so it can carry a tail. But that would be a cooler looking bird, don't you think? I mean, that's close enough to a dinosaur, don't you think? All right, well, if you like it, you like it. You don't, you don't. All right, so this is what we do. We go into the embryo. We go into the embryo, and what we're looking for, initially what we've been looking for are atavistic genes, sort of ancestral genes. You know, we all carry them. We all have genes that have been turned off during the course of our evolution. And those genes that have been turned off, a lot of them, of course, represent our ancestral characteristics. And so we are going into the bird and looking for some of its ancestral characteristics and seeing if we can turn those genes back on again. And so we were hoping that all of the three characters, all of the four characters were actually characters that were atavistic. Unfortunately, they're not. But what is interesting, teeth are atavistic. We can make birds with teeth. What's interesting is they don't have enamel on their teeth. We would have to transgenically add that, but we can get teeth in a bird. A group at Harvard and Yale recently changed the shape of the head back to looking a little more like a velociraptor. So we know that that is atavistic as well. That is pretty easy to do. And a group in Chile was able to modify the leg so that a bird really would be able to carry its tail comfortably. We've been working on the hand. We worked on it for a while. Here you can see a velociraptor, Archaeopteryx, and a pigeon, and you can see the three-fingered hand in the dinosaur and the first bird, and you can see in a pigeon basically the hand is all fused together, so it's one unit. But what's cool is that in the embryo, it's actually in 3 parts. And so that is an atavistic gene. We can stop that from happening. We can stop it from fusing together, and we can make a 3-fingered hand. What we're having trouble with is the tail. The tail is very complex, and it is not an atavistic gene. And in fact, what's happened is the tail has evolved away, and then a new kind of tail has evolved that allows the bird to actually move its tail feathers. And so what we've done now is we've figured out a way to knock the tail out, the new tail, knock the new tail out, and we're looking at ways to make a longer tail. Now, there are a lot of problems with making a longer tail. That means you're adding vertebrae. If we could figure out how to add vertebrae, obviously we could solve a lot of medical problems having to do with vertebrae. And we're learning a lot of that now, and we're also learning a lot of things about special diseases that ankylose vertebrae together, that fuse them together. We're learning a lot of things about a lot of things, but we haven't figured out how to make a long tail. And we know now that we not only have a problem making a long tail, but we think that if we learn how to, when we learn how to make a long tail, when we learn how to add vertebrae, we're not sure we can stop it from happening. And that could be a real problem. We could end up with a chickeno-snakus. So it's, like I say, this is where we're stuck right now. But we can make a dino chicken. I mean, we can make an animal that has a different shaped head and teeth and hands and arms instead of wings and a different, carry itself differently. But we have yet to figure out the tail. And so, anyway, that's what we want to make. That's what we think we can make, is something like that. Unfortunately, right now he won't have a tail, and he won't be cool looking. I mean, that would be awful looking. Just put your hand up there and go, whoa, that's, no, we don't want to do that. All right, so people always say, you have these hatched out somewhere. We don't hatch them. We grow them as a little tiny embryo. As soon as we see that it has or does not have what we want, we terminate it. So we don't have a bunch of birds running around with no tails. So what we're actually doing, this kind of genetic engineering, is exactly what we were talking about in Jurassic World. That is what Indominus Rex is. Indominus Rex is a genetic hybrid, right? Indominus Rex is the most accurate dinosaur that's ever been made. It's the most accurate dinosaur that's ever been made, right? Because we made it, right? I made it just like I wanted it. I wanted it white, yes. Well, I assume you know that that's cuttlefish, right? So basically you just take a lot of genes, you transgenically make an animal. If we had brought dinosaurs back and dinosaurs were alive now, we could make an Indominus Rex easily. We could do that. But we haven't brought dinosaurs back. You see them in the movies, and this is basically how the general public thinks dinosaurs look. And like I was saying, the Triceratops, I thought it looked like what it looked like when I had it made by the Stan Winston and his group. I thought T-Rex probably looked something like this, but these are all wrong. Birds are dinosaurs. They're not our typical overgrown reptiles. Dinosaurs gave rise to birds. And when we look at the characteristics that birds have, they have feathers, and they have wishbones, and they have hollow bones, and they have just a whole myriad of different kinds of characters. Dinosaurs invented all of them. Every characteristic that you can think of as a bird characteristic except flight, dinosaurs made first. They had them first. Dinosaurs had hollow bones. They had feathers. They had wishbones. They had everything that birds have. And so when we start thinking about, what dinosaurs actually look like, we have to use birds as the model instead of lizards. And so when you're looking at the beaks of birds have indented vessels in them. Indented vessels. And these indented vessels, these impressions of blood vessels on their beaks is actually, is what is covered with keratin. And we see it on claws of animals. Anytime we have claws with a keratin sheath, there are indented vessels under them. And so if we look at birds that have these cranial features, bony cranial features, they also have indented vessels on their surfaces as well. And we know that all of these bird characters, all these displayed features are all very colorful and they're covered with keratin. So when we're looking at Triceratops, this is an adult Triceratops. When we're looking at it, we need to think about where the keratin actually goes. And when we're looking at Jurassic Park, the keratin covering is on the beak, it's on its horns, it's on those little frill pieces around the edges, but that's all wrong. When we look at Triceratops, actually, and look at the indented vessels, they're all over the skull, over the whole thing, except in the cheek region and in the nose region. So Triceratops, it didn't look like this. We need to just get rid of that whole version and think about Triceratops like this, covered with keratin and vibrantly colored. We see that the keratin in birds, especially in males, is vibrantly colored. So now when we're thinking about horned dinosaurs and any of the dinosaurs with these great big features, these big bony structures, we need to think of them as something that is vibrantly colored. And I mean, not lizardy bright colored, but bird vibrant colors. And so this is my version of Triceratops. And as you can see, I've been working with HoloLens, and we are trying to make new dinosaurs for new games and putting dinosaurs in looking like they should look rather than like Jurassic Park and Jurassic World. Now, I know that I shouldn't say that here, but this is the reality. The reality of dinosaurs now is that they are covered with keratin over their entire face, and they probably had not little keratin-like structures around the edges. Those are probably structures that were like comb structures, like birds have on their heads sometimes. So T-Rex now, also, as we all know, probably feathered, a feathered dinosaur. As far as we know, all of the theropod dinosaurs had feathers. T-Rex also had keratin on a lot of its face. And so now as we generate dinosaurs for games, we are making them, giving them more of a bird-like characteristic rather than kind of that, the slow-moving old version of giant reptiles. And I don't know. I hope all of you, as you make games, if you make dinosaur games, will do me the favor of trying to make them more realistic and less, when I was working with Steven, I said, Steven, we need to make these dinosaurs feathery and we need to make them brighter colored. And he said, Technicolor dinosaurs are not scary. Well, they probably aren't, but let's at least try to make them real. Thank you.
Thank you so much. Absolutely fascinating stuff. We can all agree it's some really, really fascinating stuff there. Thank you, John. Thank you so much.
Oh, thank you, thank you.
Do you have some time to answer some questions?
I do, yes.
Very good. Yes, so once again, I think we'll have a roaming mic or a couple of roaming mics out there. So please put your hands in the air.
I would point, but I can see that the...
Yes, we'll probably pick the gentleman over there again, yes. Oh, actually, sorry, over on the right side. Nearer to the front there, thanks.
Pick one.
What's your favorite kind of dinosaur?
What's my favorite kind? Maiasaura. Maiasaura is the dinosaur that we have eggs of, and embryos, and babies, and 124,000 skeletons, and I named it.
Next question, please. Yes, about the gentleman in the hat with his hand up in the middle. The most awkward person to hand the mic to, sorry. Get there eventually.
Given the size of dinosaurs, do you think the atmosphere back then is likely to be much more oxygen-rich to support their size, or is that kind of unlikely? People talk about that all the time. I don't think oxygen had much to do with it. Size, we've had gigantic mammals. It's more of a, size is more of a thing where if you have a stable environment for a long time, you can get, animals will evolve bigger. Atmosphere,
Okay, next question. Got some more. What about somebody over more to this side? Gentleman at the back there. Can you see Fern? Thank you. Again, another difficult one to get to. Sorry, picking the hard ones.
We've seen how the idea of Triceratops the image of Triceratops has changed, and we've heard about your affinity for using hammers. Is there anything else you'd like to take a hammer to? Paleontologically
I take a hammer to everything.
Good answer.
Most people, when they find a dinosaur, they are very careful and they piece it all back together again.
Okay.
I don't see any reason to do that.
Somebody over on this side here as well. Time for a couple more questions. Just the person immediately close to you there.
Hello. Do you have any idea of what they sounded like if in an anime?
Yes.
Like, is there just like a T-Rex sounds like a chicken or something like that?
Well, so I have this great dinosaur hall at the Museum of the Rockies in Montana. And we needed sound in the back, and I thought, the easiest thing to do is go out and record birds and then just slow the sound way down. And it is a cool sound. And it is dinosaur sounds.
Fantastic. We have somebody
That's the answer, right? Birds. Birds are dinosaurs. They make awful sounds sometimes. And if you slow those sounds way down, they're really cool. That sure beats it, having them growl like lions and tigers, because we know they couldn't do that. There are no reptiles that can do that.
Great stuff. Gentleman on the front row here as well, I think has a question. If that's okay. Yeah, I'm sure for the mic.
There's a young girl right there in the middle.
We'll get there. We'll come back to it. We'll come back to that one. I think we've got plenty of time for actually a few more questions, so do get your hands in the air if you want to ask a question.
I went to an exhibition of Chinese dinosaurs recently in Nottingham. Did you have any collaboration with them at all? Because they had a lot of pictures. They got the feathered dinosaurs. They got various things there. Did you guys work with them at all? Or?
I think that was the American Museum in New York City.
Right, I worked with the Chinese on that one, you mean?
I think they worked with the Chinese to make that one, yeah.
Right, okay. But have you seen that exhibition? Is it sort of matched with what you've worked on?
I have not seen it, no.
Okay. No.
But I'll look for it. Were they colorful? Were they vibrantly colored? They're feathered, and
They were feathered, they were furred, they had a lot of comparisons like you've been doing now with the bird side of things. So it was it was fascinating.
Right? That if it's the American Museum, it's good they're catching up.
What about the young lady at the back with her hand up in the air? Right in the middle.
Right in the middle, yes.
How did you first get to, be interested in dinosaurs?
I was born this way. Are you interested in dinosaurs? Were you born this way?
In dogs.
Okay, well, that's good. We need people to study dogs, too.
Great stuff. Any more questions, please? On the same row, right there. Yeah.
Hello. Have you just worked with Steven Spielberg on the Jurassic movies, or have you worked with other filmmakers? Because I'm noticing that in Avatar, the big creatures there were very brightly coloured.
I didn't work with James Cameron, but on that project, I have worked on some other projects with him. Did anybody see Journey, what is it called, Journey of Time? Nobody's ever seen it. It's a Malick film. It has dinosaurs in it. I worked on those. I originally worked on Land Before Time. That's kind of dating me, isn't it? I work with a lot of people, but usually it's not as, not like I worked on Jurassic Park. When I was working on Jurassic Park, I literally was sitting next to Steven, and he would ask me questions, and I would tell him the answer, and then he would do whatever he wanted. But I had a chair and everything,
Were you tempted to make anything up to whisper in his ear?
What?
Were you tempted to make anything up to whisper in his ear?
Oh, no, I wasn't. I was trying to get real science in there somewhere. But it was fun. It was fun working with him. He's a great director.
Fantastic. Jack, if you've got, we've actually got time for a few more, if you're okay to
Yeah, I'm
go.
fine.
Is that all right?
As long as they're good, as long as I can,
We have the young
as
lady
long as they
in the
don't
middle
throw
here as
anything.
well. BBC's Kate Click here.
Thank you. Jack, if Jurassic Park were to actually happen, would you go, and would you be a good enough person to survive?
If Jurassic Park were real, I would, first off, assume that they wouldn't put it on an island and put electric fence around them. If they were smart enough to make Jurassic Park, so the dinosaurs couldn't escape, I would certainly go, yes. But I wouldn't worry very much about most of the dinosaurs anyway. I mean, Tyrannosaurus Rex, I guess it would be a good test of my theory, right? I think T-Rex was a scavenger. I don't think it would eat a live animal. But I might have a friend go check instead. maybe a graduate student.
Someone from over on the left-hand side. Here towards the front.
My question's actually for Ed, if that's all right. Regarding Frontier's new game, Jurassic World Evolution, are you planning to make your dinosaurs look more realistic in that, or will you be sticking with the classic Jurassic Park look?
What I would say is I would suggest that you wait around until the 5 p.m. talks that we have to hear more about our next title, Jurassic World Evolution. This is Jack's time, come on.
Could I see that game sometime?
Oh, you stick around. What I would suggest is that you stick around till 5 p.m. today.
Thank you.
Watch our
Thank you.
talk about, yeah. Okay, any more questions? What about the gentleman right in the center here? Yes.
Hi, sorry, I'm going to bring it a bit more serious. The DNA you were talking about earlier, do you think it's just not possible? It will never be possible to extract DNA from a dinosaur?
I think we will get DNA from a dinosaur sometime, yes. But I think it's going to be tiny fragments. Even the mammoth elephant that was found frozen in ice, the DNA is broken down. I mean, there's hardly any there. I mean, they're tiny fragments. So even to make a mammoth elephant, we're still going to have to, use a modern elephant mixture. So that's 10,000 years. So 65 million years is pushing the envelope. But I do think that someday, we have done tests and we think that we have positive results for DNA, which means that it may only be just, a couple of dozen base pairs out of trillions. So, yeah, I think we'll find some evidence sometime, but we're not going to do very much with it.
Okay, 2 more questions. Right back, somewhere in the middle. Sorry, that's very awkward for you to get to. About the gentleman in the middle over there. Zach, who wants to race? You can race to see who gets there first. Yeah, just anywhere. Anyone at all.
Good afternoon.
Yes,
where you've been modifying the chickens, obviously like working on the tails and on the legs, have you actually decided, or would you have liked to have left the egg to let it grow, or have you been instructed to actually stop the growth of the chicken?
We have not been instructed to. You can keep, as long as the embryo, as long as it doesn't hatch, you can grow it to any stage you want. But the people that actually work in the lab, they terminate it early just because.
Are you not intrigued to see what it would look like?
We know what it'll look like. And we can CAT scan them. I mean, we know exactly what they're going to look like.
Okay, one final question from over this direction, perhaps. This gentleman here has had his hand up the whole time. He's been very patient.
Thank you. Thanks, first of all, because I work for the Royal Society for the Protection of Birds, and of course I've now worked out I work for the Royal Society for the Protection of Dinosaurs,
yes.
Which is absolutely awesome. Thank you. My question was, are chickens the kind of most dinosaur-like bird, or is it just for convenience that you use those?
Say that again?
Do you use chickens as your kind of base bird, or is there another bird that's more like dinosaurs as we know?
Like I say, all birds are related. So we use chickens only because their eggs are cheapest. We need viable eggs. We need to know that there's an embryo growing in there, and so you can get a viable egg for about $5. Ostriches are really expensive. All little kids want us to do this with ostriches. But once we can do it with any bird, we can, if we do it with chicken, we can do it with any bird. But it's funny, little kids want a big one. And then they want to know, can you make the ostrich bigger?
So do big kids as well.
Okay, everybody wants a big dinosaur. So, does everybody know that the velociraptors are way too big, right? In Jurassic Park, a velociraptor is like this tall. I mean, it's just tiny. They're tiny, but they hunted in packs. That means they scaled their prey. They have recurved claws. They literally could climb up on their prey and eat their prey alive. You don't have to be big. Well, just imagine 5 or 6 of them, on their scaling their prey. I mean, to me, that's the scariest. Most birds, and you can attest to this, most hunting birds just knock their prey down, stand on it, and eat them. They don't kill them. They're not like a lion or a tiger. They don't kill their prey first. They just stand on them and eat them alive. And we think dinosaurs did the same thing. I mean, they just scaled their prey and, had lunch.
Well, on that cheerful note, huge round of applause for Jack Horner. Thank you so much again.
Thank you. Thank you.
Thank you.